Alright, welcome back to this new week, and today Monday we will be wrapping up our series on factorization, at least for now, and we'll be looking at the quadratic formula. Last week we took each day of last week to look at the various ways in which you could factorize. So we started looking at, well, the whole concept of what is factorization. Then we look at factorizing by the HCF. Then we move on to factorizing by grouping, factorizing the difference of two squares. Then we look at AC method and completing the square. So today we're going to wrap it all up with the quadratic formula. So what is our objective for today? Objective, not objectives, will be to basically factorize using the quadratic formula. And what is the quadratic formula, you may ask? This is the quadratic formula. In fact, if you are very competent with your algebra, this formula comes about when you complete the square of this formula here. So if you could complete the square of, just like this, algebraically, if you could complete the square of not a but 0. If you could complete the square of ax squared plus bx plus c, you will actually derive the quadratic formula. Very cool thing to do. So in the formula you can see you have different values. You have a, b, c, and a, b, c derived from, of course, the general or the standard form of the quadratic equation. So your a will be whatever the coefficient of x squared is. Your b will represent the coefficient of x, and your c would be your c, of course, your constant. So it's a matter of just understanding these and substituting your values. Once you do that, you should get it all right. Another thing you should know about the quadratic formula, of course, you could use the quadratic formula whenever every other single strategy doesn't work or cannot work for whatever reason. If you need to find the values of x, the quadratic formula will never fail. Even if you're ending up with imaginary values, that is what it is. You will end up with imaginary values. It will never fail. So sometimes you might try using the AC method, and you notice that, okay, you cannot find two factors of AC to give you B. Then you try grouping, but then it doesn't work. Then you might try what? The HCF, and again it doesn't work. But whenever you try to use the quadratic formula, it will always work, even if you end up with imaginary values. Of course, at the high school level, you will not end up with imaginary values, or often if you do, then that means you're supposed to do something else. But at the higher levels, we know that all values are possible, and imaginary values also exist. So let's see how we use this formula. So first thing, of course, it's wise to state which is which. So you know, state what is A, what is B, what is C. So in this case, we know A is 2 because that's the coefficient of x squared. We know B would be 5, and we know C would be 3. And that's all you need to know. After that, then you just apply the formula. I usually advise writing the formula first. So x is equal to minus b plus or minus, minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And now that we have our formula, we're looking for the possible two values of x, and we just substitute what we have. So we know b is 5, so here we will have minus b, well, minus 5, plus or minus the square root of b squared, which is the same 5 squared now, minus 4. We know our a, look at it here, is 2, and we know our c, look at it here, is 3. So we just substitute those values there, all divided by 2a, and again a is still the same 2, so it will be 2 times 2. And once we do that, that's it. It's just a matter of simplifying now and see if we could get our values. So let me just simplify one step further. So that leaves us with minus 5 plus or minus the square root of 25. When I square 5, I get 25. That's 5 times 5. Remember, 5 squared is the same as 5 times 5, just to be on the safe side. And 5 times 5 is 25. And inside the bracket now we have 2 times 3, we could say that is 6, and 6 times 4, we know that will give us 21. And that's all divided by 4. Yep. At the top now we have minus 5 plus or minus the square root of 1. 25 minus, oh, how did I get 21? It's supposed to be 24. I said it and I write 21. So yes, it's 6, 2 times 3 is 6, and 6 times 4 is 24, not 21. So 24 and 25 minus 24, because I did it before, I know the answer, so I guess I'm running ahead of my thoughts as usual, talking much faster or much slower than I'm thinking rather. Good. So here, of course, we have minus 5 plus or minus the square root of 1, all divided by 4. And that will leave us with two possible, oh, the square root of 1 is 1, by the way. So this leaves us with x being equal to either minus 5 plus 1 divided by 4, or we will have minus 5 minus 1 divided by 4. And let's say if it's this first one here, then we have a value of x being negative 1. Minus 5 plus 4 is negative 4. Negative 4 divided by 4 is negative 1. And over here, we will have negative 6, negative 5, negative 6. Negative 5, negative 1 is negative 6. So we will have negative 6 over 4, which can break down to negative 3 over 2. So, as always, whenever we have a quadratic, remember we factorize, we'll end up with two values for x. So here, x is either to negative 1 or x will be negative 3 halves. Either or. So either x is negative 1 or x is negative 3 halves. Oftentimes, these two values is what we form the roots, and the roots is what we get when we try to, of course, equate or sketch a graph. So like I showed last week, if we have our Cartesian plane, our roots would be these points here. These are our points which we call roots, or we sometimes call them solutions. So this is what these two values of x would tell us. So it would cut the x-axis at negative 1 and negative 3 halves. So that's basically how we use the formula. But again, you don't need to go all the way here. Well, yeah, you may. As he said, they could ask you to sketch. So if they sketch it, last week I showed you by completing the square, you could find a turning point. Good, whether it's at the bottom, whether it's at the top, or minimum or maximum. And when you use the quadratic formula, or when you solve for x after you do the AC method, you could find your roots. So you could sketch a little more accurate than just estimating the location, right? Good. So here we have two examples, and of course this is the time where you attempt it, and then I will see if we get the same thing. But you could pause. No, yeah, you could pause and attempt it. I would not pause. I will move on, right? So I'll start with number 1. And again, as usual, I find out or I pinpoint my A, my B, and my C. So in this case, my A is 5, my B is 6, and my C is 1. And then I state my formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac. And it's nice to state the formula, by the way. The more you say it, the better it stays with you. Although, of course, it is not required to memorize this anymore, because for CSEP, you actually get this formula in your formula sheet on the front page. So really and truly, there's no need to memorize it. But again, I would always say it saves time when you know it than to flip a few pages behind. Good. So now we have our formula. Let's just substitute our values. So in this case, our b is 6. So then we have minus 6 plus or minus the square root of b squared, which is 6 squared minus 4. A is 5 and C is 1. So we put it like that, and then that's over 2A, and A is 5. So that's our substitution all done, and check. So then we solve now. So this leaves us with minus 6 plus or minus the square root of 6 squared, which will give us 36, plus 4, or how to put it? Okay, 5 times 1 is 5, and 5 times 4 is 20. No, 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 no. Why did I put a plus there? Minus 20. Good. And all that's divided by 10. Taking it up here, simplifying further, we end up with minus 6 plus or minus the square root 36 minus 20, that would give us 16. And that's all divided by 10. And then you find the square root of 16. You need a calculator for that, unless you know your perfect squares. I know 16 is a perfect square, so I know this would leave me with minus 6 plus or minus 4. If you don't know how to get that 4, you just have to get your calculator and square root. So you just look for this sign on a calculator, and then you click 16, or you press 16. Or based on the calculator that you have, you might have to press 16 first, and then you press this knob. You will see it like this. Sometimes you might see something like this. How else do they show it? Yeah, that's how they usually come. And of course, you have to know your calculator. Sometimes you have a designated button for it, or sometimes you have to use second function or shift, and then maybe the square. Usually they associate, you might see a button like this. Yes. So usually this button, so on your calculator, you might see this, and then you will see this on top it. Or some calculators, they might have the designated button as a square, and on top it, they have the square root. So again, you just press shift on your calculator, or you might see second function, so second, and that will help you to square, or square root rather. Well, whichever one. If you have to square, you could do that. If you have to square root, you could do that. Right, and you should get 4 there. Right, so moving on. And from here now we could solve. So we have two values of x as usual. So either x is equal to negative 6, negative 4 divided by 10. Wow, these questions are working out pretty nice. Or x could be equal to negative 6 plus 4 divided by 10. So if it's the first one, x will be equal to negative 1 again. Or if it's the second one, negative 6 plus 4 is negative 2. And negative 2 over 10 is the same thing as 1 over 5. So either x is negative 1 or x is, let me see, yes, this is supposed to be negative 1/5. So it's either or. I trust you got this answer. This is our final answer here for x. Let me just confirm. Minus 6 plus 4 is negative 2. 2 could go into itself once, and 2 could go into 10 5 times. So yes, that's it. So yes, if you got this, you're on the right track. Let's try the last one, number 2 here. And again, I'll just identify my values. So I know that A in this one is 6, like the one we just did. B in this one is 7, and C is negative 3. Be careful with these. Yeah, see, it's negative 3 and not just 3. I've seen students sometimes just pay attention to the number and they ignore the sign. Respect the sign. And then I will draw my formula, not draw but state. So x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. And now that I have that, I could substitute my values. So b is 7, so that will be minus 7 plus or minus the square root of 7 squared minus 4. A is 6 and C is negative 3. Good. And all that's divided by 2a, and a is 6 again, so I'll just put that there. And I'm simplifying now. So minus 7 plus or minus the square root of 7 squared is 49. That is 7 times 7. And here I could foresee already that I'll end up with a plus sign because there's a negative. So it's 18 times 3. Again, you see what I'm doing there? I'm calculating faster than I'm thinking. Anyway, so it's, hold on, let me get that again. So it's 6 times 3, that is negative 18. Good. And then we have 18 times 4. So 6 times 3, this will give us negative 18. And then we have 18 times 4. And a negative will give us a positive. And that's how we ended up with positive 72. And all that's divided by 12. I hope that makes sense there for you. So in essence, we just multiply everything that is inside there. And when you do that, you will pretty much end up with that value there. Good. But I ain't done yet. So we have minus 7 plus or minus the square root. If we add 49 and 72, you should end up with 121. 121. Let me just confirm. So you have 49 plus 72. So 9 and 2, that's 11. We have the 11 there. We take out the 1, and the other one comes here. So that's 7 plus 5, and that is indeed 12. Right? So just confirming. Good. Let's erase that. And all this is divided by 12 still. Good. 121 again is a perfect square. So that is minus 7 plus or minus 11. 11 times 11 is 121. All divided by 12. So here we have our two values of x. So it's either x is equal to minus 7 minus 11 over 12, or I say plus, or x is equal to minus 7 plus 11, all on 12. Yep. So when I solve this first part here, I should end up with negative 18 on 12. I'll break down just now. Negative 18 on 12. Or on this side, if I break down, if I compute 7 minus 11, this should give me what? Negative 4? No, not negative. I keep this sign of the bigger one. So this is supposed to be 4 over 12. And this also could break down. So this will break down to a quarter, no, a third. 4 could go into itself once, and 4 could go into 12 3 times. And here, what can I use? I could use 6. 6 could go into the top 3 times, and 6 could go into the bottom twice. Yep, so there you go. So x is either 3, negative 3 halves, or x is 1/3. Yep. And easy does it, people. This is basically how we use the quadratic formula. So whenever you're asked to factorize, this is always an option. However, I could tell you for a CXC or from experience, oftentimes they tell you to use the quadratic formula. Students hardly go for the quadratic formula if they have a choice. So always be aware that you need to be able to use it in the event that you're told factorize using the quadratic formula. Other than that, it's always open. Whether you get an expression, an equation, you could use this. And you will be able to find, well, it wouldn't make sense with an expression. But with an equation, any day, it will work. So this will be the end of today's video and also the end of today's series on factorization. Tomorrow, God willing, we're going to continue with our geometry, and we're going to be wrapping it up with calculating the area, circumference of a sector, a circle, a segment, and the length of an arc. So that we'll do each concept per day, so it wouldn't be too weary. I think tomorrow we'll be starting with the circumference. So until then, you take care. This is Everything Mathematics. Subscribe if you haven't as yet. Share with somebody. And of course, enjoy the rest of your day and week. You take care.